Hello and welcome to our discussion of Section 4 exam for the CQI. This deals with calibration and it's really, it's kind of basic. There are not a lot of detailed questions in this exam. It also is one just like the previous exams. Several of them could be answered from the glossary and from the PowerPoint slides that we use to discuss calibration. Certainly not all of them will be in the textbook because as we talked before, the textbook is only one of several sources. So in many cases, you're going to find the answers to be better to go look in the glossary first if it presents itself. So let's go through a discussion of each of the questions, and we would also mention that your exam may be slightly different than what we show here because we're always changing the exams to make them fresh and to make them better. And so it could be that there will be a question or two added, maybe replaced, but it won't interfere with the overall value of the exam. We don't re-record every time we make small changes. If you have any questions, never hesitate to get a hold of us. We'd like to make sure that there's complete understanding of the rationale for the answers. Now, we're not going to go through the entire solution in the solution box. We're just going to hit on a few things that would lead you to the right answer. Number one, which of the following is the procedure used to restore measuring instruments to original accuracy capabilities? Now, when we go through and look at each one of these answer choices, certainly they present them well to have a quick reference to the glossary. But we would find A, C, and D really to be distractors. This really is talking about the heart of what this exam, this section is about. Calibration. So that's what we use to make sure that the measurement instruments are, is very accurate. 2, what is the primary means? Now, when you see a word like primary, you need to be thinking that there's going to be more than one seemingly correct answer. And in some cases, they all might be correct. I'm not talking about this particular question, but in many questions where some word like that pops up, they all might be correct to some degree. But what is the primary means by which humidity affects calibration of high precision now, not just scales and balance, but high precision equipment? And certainly when we look at the A, B, and D, these are intended to be distractors. A, high humidity will corrode reference standards. Yes, high humidity will absorb some moisture, but masses takes on a whole different perspective here. Certainly, this is one that requires a little bit of logic, a little bit of thought, but C is the correct answer we're looking for in this particular question. At 3, the local acceleration of gravity. Now, local acceleration. Gravity is affected by geographical location. So depend on where it's located. So the local acceleration of gravity can affect calibrations of which of the following parameters. Now, gravity affects pressure, it affects force, and therefore it affects torque. So this question could be showed up on the exam. We could have used, instead of torque, pressure, force, and it would have still been correct. Obviously, in an ASQ exam, they will not give you on the same question likely torque, force, and that type of thing, because they would all be correct. Luckily, it's not asking for the most correct if you had one like that. 4, although quality assurance. Now, when we think about quality assurance, we got to think about planning. We got to think about things like prevention. improving quality, and that type of thing. But although quality assurance activities cost money to implement, everything costs money, right? The quality community believes that these efforts most often results in a positive offset. In other words, we spend money, but we get our money back plus more. Which of the following statements best demonstrates this belief? Well, A and B have some validity. They're true to some degree, but neither one of these are the best answer choices, and that's where many questions are a little more difficult. C, they enable participate in inner laboratory comparisons. Well, no, that's not the best reason for this, for doing this. They greatly reduce the need, quality assurance activities greatly reduce the need for traceback analysis and rework. When we do quality assurance, that is considered a prevention cost, and typically prevention costs nets a 10-to-1 payback. So certainly D speaks to that benefit. 5, for a typical set of measurements, which of the following refers to its standard deviation? Now we're talking about standard deviation here. Really we're talking about test uncertainty ratio. And when we go through and read the answer solutions here, when we're talking about standard deviation, we're talking about test uncertainty. It really leads you right to the answer choice, and that's C. So standard deviation speaks to the probability of uncertainty of measurement. You would have found that in the glossary, actually. That wasn't in, that I could find in your textbook, though. 6, what does precision in a measuring device means? Well, you have to, again, take each one of these answer choices and define the right answer. A is really talking about precision. B is talking about accuracy. And C is a definition repeatability or precision of the measuring device. But it's a little bit off center here. But D is the correct answer. How close the readings will be when they're measuring the same part different times. Seven, a calibration system provides for the prevention of inspection equipment inaccuracy through which of the following? Well, A is proper oiling. You know, that's really intended to be a distractor, but, you know, could it have an effect? Yeah, okay, but it's a weak choice. And then when I look at B and C, these can be really considered subsets of D. D ends up to be the broader answer choice, total equipment coverage. So when I'm looking at total equipment coverage, that's the broadest answer choice, which in an ASQ exam, the broader answer choices are correct most of the time, a high percentage of the time, actually. So when I pick D, I also include B and C. B and C would be restrictive, so you want to stay away from more restrictive answers. 8, which of the following is the basis for establishing calibration intervals? And this is, you know, kind of a logic, but it ends up to be in the glossary, looking up calibration intervals. You could find, we talked about it in the slide material. It's talked about in a military standard. It's in your textbook, and that's B, stability, purpose, and degree of usage. 9, when calibrating a piece of equipment, the most important consideration is now most important is like primary. When you see a term like most important, there will be more than one, could be more than one seemingly correct answer. And when I see B, C, and D, B, C, and D, you know, is important to have, good to have. You know, calibration sticker, we know when the piece of equipment was calibrated, when it's going to be calibrated next, who calibrated it, that type of thing. Certainly, a calibration interval is certainly important. Certainly, maintenance history card, so we know the history of that particular gauge. That's good. But the standard used is really the most important consideration when it comes to calibration. Which standard are you going to use? 10, the accuracy of a measuring instrument is linked to the U.S. national standards by, and again, when I look at A, C, and D, we put those in to be distractors. They're incorrect, and you can see why each of those are defined and doesn't address this question. And traceability is the answer to this question. Could have found it again in the glossary or in the slides and other places. And it's in Walker's textbook. 11, a master or reference gauge is used for the purpose of checking which of the following. And again, when you look through that, those answer choices, B will come out to be the correct answer. Its purpose for checking the working gauge for accuracy prior to measuring the product. You know, like if you had a master ring for a dial bore gauge, if you've ever had experience with that, that would be setting out at the workstation, and we were trained anyway, every time that you either used the gauge, if it had been a while during the shift, you would master it or check it. It depends upon, in a lot of cases, how critical the characteristic is, or at least from my experience. But many times during the day, whether you did it in between checking a piece or you did it every so many pieces, but you check to make sure that it was accurate, because little nibs can wear, they can get loose, a lot of things could happen, so you want to make sure you're checking that quite frequently to make sure it's okay. 12, which of the following is the best course of action that should be taken when test and measuring equipment is found out of tolerance at the end of calibration cycle? Now, best course of action means that there could be more than one seemingly correct answer, and you're looking for the best. One of the things that I would remark to you that in a lot of exams for questions, exam questions, the longest worded answer choice is correct most of the time. So the advice is, when you're in an exam and you can't figure out what the answer is, and you rule out the ones that you can, if you're down to 2, pick the longest worded answer choice, because it usually is the broadest answer choice, which tends to be right most of the time. Certainly 75, some people say 90% of the time. So when you look through the answer choices, calibrate the equipment with no further action. Well, that's kind of dangerous. You're out of tolerance. You're just going to recalibrate or calibrate the equipment, adjust it, and you take no action. Well, that's not very good. That could lead to some dire consequences. B, this would be automatically recall all product and reinspect after calibration. Well, what if it's just slightly out? Why would you recall all the product? That's kind of aggressive. That may be something you do, but that is not something you're going to automatically do without doing some investigation. C, disregard, since this does not happen very often. Again, that's like A. That's kind of dangerous. You're not going to ignore this. You got to take some kind of action. So D is the right answer. Review for possible effect on product already inspected by the equipment. And then you make a determination. Hopefully you got product in-house. And hopefully then it leads you to make a decision whether or not you need to call everything back. Obviously, I'm one that's don't take risk. I'll be willing to call product back, but only when it makes sense to do. If I don't have product that is in jeopardy of not fulfilling the customer requirements, and I check parts in the house, the gauge is slightly out, but maybe I'm running right on the target. So even though the gauge might be slightly out of calibration, the parts are within specification. So you want to be careful of the action that you take. 13, when should calibration intervals be adjusted? This is like an earlier question we had, and some of these are kind of nonsensical, really. Only a few instruments are scrapped during calibration. Well, I'm not sure what that's telling you. It has nothing to do with calibration intervals, really. And then no defective product is reported as acceptable due to measurement errors. Again, that's one you want to ignore at this particular point. I mean, that's something that you want to have happen. There's no defective product. Okay, that's what you're supposed to have. So, why would you adjust the calibration intervals just because you had no defective product? You're supposed to have that anyway. And then the results of previous calibrations reflect few out-of-tolerance conditions here. And again, that should be fairly normal. That's what we should have. C is the right answer. A particular characteristic on the gauge is consistently found to be out of tolerance. Then you want to adjust it. You're probably going to reduce the calibration intervals to some point, whatever makes sense to do. That's been on exams before. 14, precision and accuracy. When making measurements, would test measurements mean the same? Well, precision and accuracy are two different things, but they're not exactly opposite. So you want to ignore A and B. And the answer is C, consistency. You could look this up in the glossary. You could look up precision. One of the things for precision is consistency. Accuracy is the same as correctness. Okay, so again, a little bit of logic using the glossary would be very helpful for you. The thing about exam, when you're timed, you want to make sure that you have an adequate amount of time to review answer choices. Time will not be an issue. I've had some people with the CQI report that they actually got done in less than an hour. That's not normal, but they had a lot of time to review the correct answer choices, and we will talk about that as we get down close to the end or at the end and giving you some pointers on how to handle the exam. 15, which of the following is an unimportant aspect of the control of measurement standards? Now, unimportant is a negatively slanted word. So when you hit one of these, you're looking for the outlier. And sometimes they can become confusing. So if you turn the word positive, in other words, replace unimportant with important, you turn it positive. And sometimes that makes it very clear. Well, what I call the correct-incorrect choice in this negative is procuring all working level standards directly from NIST. Ooh, man, now again, working level. And directly from NIST, National Institutes for Standards and Technologies. Yeah, I don't think I want to do that for working level standards. And so certainly what's important is determining calibration intervals and measurement standard sources. That's important. Developing a listing of measurement standards with controlled nomenclature. Yeah, that's good. And then D, maintaining proper environmental conditions and traceability of accuracy to NIST. Yeah, that's good too. So that's why the value of turning a negative slanted word to a positive, then you can easily pick out B, C, and D are important. The least important, or the unimportant one, is A. You don't need to buy from NIST for all working level gauges. Hopefully that makes sense to you. Which of the following is the best definition of accuracy? Now, best definition means that there's going to be other ones that might sound right. Correct answer obviously is A, but B is talking about precision. which is different than accuracy, and then C, getting the best, using the best available measuring device that's available. Well, that could be very expensive. Why use a very expensive gauge, let's say, usually they're the best available. Why use that when you don't need to? That could be very expensive. And then reading to 1 decimal greater than expected dimension, well, that's sensitivity. So this is like an earlier question, and it's more of a definition. I think we have one repeating similar to this a little bit later. 17, which of the following is correct versus incorrect as it applies to measurement error? We talked about measurement error when we talked about calibration in our overview. Certainly, measurement error is due to a lot of things, equipment, users. So it's not normally the fault of the user. Usually the biggest part of measurement error is the equipment. I wouldn't call measurement error of little consequences. And D, it can be eliminated by frequent calibration. Well, no, calibrations is not going to affect measurement error. Measurement error is what it is. But we can determine measurement error, okay? By doing GR&Rs, we can determine measurement error and the effects of the user and the gauge and the environment. 18, which of the following is correct as it pertains to precision? A little bit like the earlier one that we had. Using extreme care in the analysis of data. Well, yeah, you want to use extreme care when you're analyzing data. Well, okay, that's a truism basically, but that's not addressing this question. And then you can read these others, with C isn't really, you distinguish small deviations from the standard value. That's really not precision. Precision is getting consistent results repeatedly, time after time after time. 19, which of the following factors is least likely to be influenced by the inspector measuring the distance between any 2 points here? Least likely is not exactly a negative, but it can be treated that way in that you're looking for the outlier. You're looking for the one that doesn't make sense, that doesn't fit the pattern. Well, the answer here is C, true distance between 2 points, the true distance. The inspector can't influence the true distance. Nobody can. It is what it is. Whatever that true distance is, what the inspector is doing is measuring what that distance is, but the true distance, he or she can't influence that. 20, typically measured and test equipment are calibrated to, and again, I'll let you read through the answer choices here. The right answer is determine and or assure their accuracy. D is the opposite of D, really. You don't use M&TE to check the validity of reference standards. It's the other way around. And government doesn't have any regulations for M&TE. Doesn't mandate that all equipment be calibrated. 21, a fundamental requirement. Fundamental requirement. Now this is going to be something basic. Of most gauge calibration systems specifications is that, well, when I look at A and B, I ought to consider that. We talked about that. Got to be identified with a unique number when you're setting up your system. But look at the answer and then see. So what the thing about like A and B, these are very specific. So if I pick A, that's the fundamental, having an ID. Or I pick B, they got to be color coded. Not all gauges are color coded and must be color coded. It's good to have. Where I worked, we did have color coding for the different calibration intervals. And then C, all inspection equipment must be calibrated with master gauge blocks. Not all equipment is calibrated with gauge blocks. So C would have been maybe the first one you would have discarded. And then D, equipment must be labeled. Well, you know, we're talking about labeling up in identification, but labeled or coded to indicate date calibrated by whom and date for next calibration. This is fundamental. Now, whether you color code it or whatever, but D is the fundamental requirement. This is basic. It's the broadest worded answer choice, which makes it correct a high percentage of the time. Then 22, which of the following functions are necessary to have an acceptable calibration system covering, measuring, and test equipment in a written procedure? So this deals with written procedures. And when you look at B and C, they can be eliminated because sensitivity and humidity control are not major functions. And then, you know, D is really the right answer here. Calibration sources, calibration intervals, calibration environmental conditions, and controls for unsuitable equipment. That's what's necessary to have in a written procedure. 23, which of the following is most representative? Again, most representative means there could be more than one seemingly correct answer, but we're something representative of sensitivity. So really we're looking for a definition. And when we're dealing with sensitivity, like we had show up really on a couple earlier answer choices, the ability to identify small differences in the response variable or differences in the response variable, some words to that effect. 24, according to ISO 10012-1 and ANSI Z540-3, calibration intervals of M&TE must be based upon which of the following must be. Now this is like an earlier question, very early in the exam, but equipment stability, purpose, and degree of usage. Now this isn't unusual in an exam, especially in an ASQ exam. That's why a lot of times in my exams I will reword either the question or the answer choices to try to throw you off a little bit, but that's the way a lot of times in an exam that happens. In a 100-question exam that you're going to have, this could happen 3-4 times at least, to have similar worded questions, just to see how depth your understanding is. 25, which of the following should be included on the calibration label of a piece of M&TE, measuring and test equipment? B, C, and D are just put here for distractions. You don't put a procedure or even a procedure number on the unit. You don't do that, and you don't identify the measurement error, the instrument error, or the identification of the person who performed the calibration. Now, we do a lot of times put names or something, initials or whatever, on the piece of equipment. We do that sometimes for traceability, but that's really not what we're talking about. What's most important is the due date for next calibration. And again, sometimes the due date might be just, it can happen anytime in a particular month, let's say, and maybe you got a different color code for the month. Maybe it doesn't actually have a date, but it's got a color code. I've seen it both ways. Typically in the factories I've worked in, we use color coding plus a date. 26, under which of the following conditions should calibrated intervals be reduced? Again, this is a little bit like an earlier question, but when we closely examine the answer choices, A and D really are talking about things that situations that you would lengthen, expand the interval, like the equipment usage decreases, gets smaller. Now, we're not using it as much. Well, then you might lengthen out, because a lot of times it might be setting in your gauge drawer. The results of previous calibration show that accuracy will not be adversely affected. Well, that might be that you want to lengthen it and not reduce it. And then B, an audit team decides it is necessary. Audit teams don't make any decision about accuracy or intervals. They just report what they see. The answer here is C. Previous calibration records indicate the need to reduce it, to do it more often. 27, since all standards are traceable to a grand standard, arrange the following elements in an appropriate downward sequence. This means starting at the top, going down. Now, this might be the first one you've had like this. We're starting to see less of these in an exam, but we still see them. The best thing to do is look through the answer choices. We had a slide dealing with this. Work center, metrology lab, and so on, and either pick out what you think would be the most, or the top, the most important, the highest level, or to the lowest one. And you'll see if we could pick out, let's say that NIST is at the top, like on that pyramid that we showed you on the PowerPoint slide, then we can pick, well, 5 is the, item 5 is the number one, it's the top of the list. Well, a quick glance down here would show that A and C then can be eliminated, and then B and D would be in consideration. And certainly in this hierarchy, Work Center is at the lowest sequence. So that's item 1. So you'd look back down to B and D, and you'd pick item, oh man, D is the only one that has satisfies these requirements. You don't have to look through every one of these. Pick out which is the most important or the highest level, depending on how the question is, and the lowest, and you got your answer typically. Now, one thing that I recommend is always, as you have one of these, look down first to see how the answer choices are laid out. For instance, maybe, not in this situation, but maybe every one of the answer choices starts with item 5. Okay, well then the next thing, because if you pick out the top one, the most important, then it doesn't do you any good to pick that one out. You would look then for maybe what the last one is. What is the one that has the lowest in the sequence? And in this case, it would be item 1. And if you could pick out what that one is, you got your answer. You don't have to, try to, okay, what comes first, what comes second, what comes third. These can be pretty easy once you understand how to work. 28, the calibration of measuring instruments is necessary to maintain accuracy. Which of the following is indicative of how calibration affects precision? Now, this is basically, we talked about this in a slide, but it's kind of logic, and you would find, D, precision generally stays constant over the working range of instruments. And this is the right one, and you can see A, B, and C. We talk about those in the solutions box there. 29, when the same gauge is checked by comparing the results of different inspectors and taken at different times. That's important. It's not same. A reference has been made, is being made to the gauge reproducibility. So again, you don't have same gauge, same inspector, same time. You're looking at, can we reproduce that measurement? D is the right answer. 30. Most dimensional standards are calibrated at a specified temperature, with the accuracy being higher on equipment closer to that temperature. Which of the following is the temperature at which most standards are calibrated? This is fundamental. It's basic. You have gauge labs or whatever, and they're kept at 68 degrees. You could have found that in the glossary and other places. It's desirable to do a GR&R study of a gauge and compare it to the total process variation. However, which of the following must be assured about the gauge before conducting that GR&R study? And you would find that in the glossary as well. and that's accuracy and sensitivity. You need to know that before you do the GR&R. 32, which of the following can determine the repeatability of a GR&R study? And again, this is one you just got to go through reading the answer choices and logically trying to figure out which is the right answer, which you would find B, examining the variation between the individual users and within the users, measurement readings. Some of these are distractors or filler choices. Meant to sound good, but not accurate. 33, which of the following is the definition of an interim measurement standard? Something I'm going to use before I get a permanent standard. That's what A is saying. And some of these are, got different meanings here. So this is just a basic definition. I don't have that in the glossary because it's so fundamental. 34, which of the following U.S. organizations maintains primary reference standards and the copy of the International Kilogram, or a copy? And that's NIST. Okay. 35, which of the following is determined from the data from a GR&R study? And what we're trying to, gauge reproducibility and repeatability, GR&R. So that ends up to be D. That's what we're trying to find out from, accuracy and sensitivity. We know before, should know before doing the GR&R. 36, which of the following is the term to describe the slow change over time of a measurement characteristic? And that's just a definition really of drift, a slow change over time. So just a definition. 37 is also just a definition of drift. Okay, again, a little bit just like this 36, but it just changes it around. And so one, the answer is drift. The other one, we're asking you about drift. Which of the following types of measurement errors caused by drift? Well, that is equipment variation is what generally causes drift. 38, which of the following standards provide the guidelines for meteorological confirmation systems for those organizations with quality management systems certified to ISO 9001? You would find that in the glossary. Just go look for ISO 10012. And you would find that answer. 39, the 10-to-1 calibration principle that we talked about in the PowerPoint slides can be interpreted as the ratio of, we also had that in the glossary, the calibration standard accuracy to calibrated instrument accuracy. So that's what's called the 10% rule or the 10-to-1 rule. That's kind of going out, like we talked about, that's kind of going out, with the sophistication of gauging today that may not be accurate today, but it still hangs around and probably will be as long as I'm still involved. I don't see it changing any. 40, a tool that has just gone past its calibration date. That might be the next day. And you got to pick out using some logic, what the best answer is. A, may be used for the next 30 days without risk. Well, my experience with calibration is there's nothing in any standard that says that. B, is considered defective and must be immediately removed from service. Just slightly out, not necessarily is that true. You may not have another gauge to put in its place either. Until you get it calibrated. C, has a considerable increased risk of giving incorrect readings if use continues. Now, it's just gone past its calibration. So a calibration might be maybe, let's just say 6 months or whatever that might be. And you're just gone past by 1 day, even if it's 3 months, just by maybe one day or one shift. No. Use some logic here. D, has a slightly increased risk of giving incorrect readings if use continues. Now, usually in calibration, it's just like anything else. So you figure out the gauge is good for calibration on this period, and then you back up from there. You don't want to go to the maximum length. So if it's just slightly out, you're probably not going to affect any of your readings. Definitely you want to get them calibrated and get them calibrated in time. Certainly, that's the best process. 41, a torque wrench is calibrated at a specified distance from its center of rotation. If this length is changed, it would. Now, we talked about torque wrenches, I think, under metrology. So we didn't really talk about that again, I don't believe, in calibration. But if you remember about torque wrenches and in the metrology, you know, using the right length on the handle and whatever affects it. So if this length is changed, it can result in inaccurate readings, and most of the time it does. The last one. Which of the following is a true reason why scales and balances should be calibrated after they are moved? Well, it has something to do with what we talked about earlier. Gravity is, a function of geography, where things are located. Remember the local acceleration of gravity? So if scales are moved, they should be calibrated again because gravity is different in different places. So with that, we're going to end our discussion today. Again, I implore you, if you have any questions, never hesitate to get back with me. And, there's no foolish question, ask if you don't understand so we can talk about how to make it more clear for you. With that, we'll let you go and have a good day.